we are going to look at an application of an exponential function. So they are telling us that the half-life of nitrogen 13 is approximately 9.97 minutes. And so they're asking me to determine the value of A, so that when we look at this formula where capital A of t as a function of time is equal to an A sub 0 times your A to the power of t. And they go on and tell you that t is representing your number of minutes. This A sub 0 is the amount you have at a time of 0. So when you first start out, and they want 6 decimal places. So let's just pretend like we're going to start with 50 grams of a substance, or of nitrogen 13. We're going to start with 50 grams. Now, we don't know what A is, but that gets multiplied by A to the power of T, which is the half-life. In this case, we're going to say 9.97. So if that's the half-life, that's how much time it takes to reduce our initial amount of nitrogen 13 to half the amount. So if we started with 50, this has to become 25. Now we're going to solve that for A. So we have to get A by itself. That means we're going to start by dividing both sides by 50. And no matter what you started with for your A sub 0, we're going to all have the same fraction right here because we have half left of what we started with. And so we are solving for A. And the way that you get A by itself is whatever power you are raising A to, you can take the same root of that number, which is the same as raising it to the power of 1 over whatever that power was. And so whatever we do to one side, we do to the other. So 1 over the power of 9.97. So that actually cancels the power here. So you just have your A left. And then if you get on a calculator, which is what I did here, I got on my Desmos scientific calculator, make sure you put that 1/2 in parentheses, and you're raising it to the power of 1 divided by 9.97. And so you'll notice with 6 different decimal places, my A value is 0.93288. And so notice that the 4 here tells me to leave that 8 as it is. So there is my value of A for that formula. Now going forward to step 2, we're going to need that value of A, because now they ask me how much of a 3-gram sample of this nitrogen 13 would remain after 8 minutes. So we are looking for A, the amount that would remain after, in this case, 8 minutes. So we're starting with the 3-gram sample. We're going to multiply it by the little a that we found in the previous problem, which was 0.932838. And in this case, we're looking at 8 minutes, so we have to raise that to the power of 8. So at this point, it's just a matter of getting on my calculator and punching it out, which I did down here on Desmos. And you'll notice that with 3 decimal places, we are going to be left with 1.72. The 1 here tells me leave the 0, so 1.720 grams in that case. And then finally for step 3, this time we're looking at the same 3-gram sample, but we're looking at 5 minutes, and we're trying to decide how much of the nitrogen 13 we would have left after 5 minutes. So we're starting with our 3 grams. That gets multiplied by the A we found from step 1. So 0.932838 from step 1. And this time we're looking at 5 minutes. So again, if we punch that out on our calculator, after 5 minutes, round it to 3 decimals, we would have 2.119 grams.